friends to my channel Making Maths Fun, and today's video is about calculating I to the power I, that is iota to the power iota. That is, I is a complex number, the simplest complex number we can think of. So a complex raised to another complex number, and when we calculate you will see that it is resulting to a real number. Let's see how it works. So what we need to do is we need to calculate I to the power I. Now this can be written as I to the power I whole to the power 1, and this 1 can be written as natural log of E. So I can write this down as natural log of E. Now according to the base change rule of logarithms, when I'll write down here, when a to the power log b is there, it is equal to b to the power log a. Whatever may be the base, say it is c. This doesn't matter. These two can be interchanged. So same here, we will interchange I to the power I with e. So we get e to the power natural log of I to the power I. And this I is in power, तो ये product में आ जाएगा. So this can be written as e to the power I natural log of I. Now let us calculate natural log of I. So let us take the Argand plane. Argand plane is a plane in which all the complex numbers are represented. So say this is Z, the complex number, any random complex number which has a distance of r from the origin and an angle theta. It makes an angle theta with the real axis. So say this point and we need this point. So based on this triangle, this point will be r cos theta and this point will be r sin theta. So these are the two coordinates of z. So based on this, z can be written as r cos theta plus I times r sin theta, because this is the imaginary component, so it will be multiplied by I. Now if I take r as common, so this becomes cos theta plus I sin theta, and according to the Euler's formula, cos theta plus I sin theta can be written as e to the power I theta and r can be multiplied to it. So this is z. So z is equal to r into I to the power r into e to the power I theta is the format. Now in our case we need to find out, let us take I. Z is I in our case. So this distance from the origin is 1 unit, right? And this angle is pi by 2, pi over 2, that is 90 degrees. We can also do one thing, that we can complete one rotation and then again go to pi by 2. That means pi by 2 plus 2 pi, a complete rotation. And we can add more 2 pi's to it, say pi by 2 plus 4 pi, pi by 2 plus 6 pi. So that will become, we can write it down as 2 pi n, pi by 2 plus 2 pi n, where n is an integer. So now this is our angle, 1 unit is the distance and the complex number is I. So let us put these values over here. And this is 2 pi n plus pi by 2. Let us take the natural log of both sides. So this will become natural log of e to the power twice pi n plus pi by 2. Now natural log of e will become 1 and this whole thing which is in power according to the log rules will come as a product. This is 1. So this will just remain this much. So natural log of I is equal to I times twice pi n plus pi by 2. Now let us put this value of natural log of I in this thing. So what we get is I to the power I is equal to e to the power I times natural log of I, which we have calculated to be I times 2 pi n plus pi by 2. And I times I is I square, which is minus 1. So this whole will be multiplied by minus 1 and we get e to the power minus 2 pi n plus pi by 2. So that is the value of e. That is the value of I to the power I. So you can see we have given I to the power I, that is complex number to the power of complex number. But in this thing, e is a real number, 2 pi by 2, they are also real numbers, and n is an integer. So this whole thing is a real number. And we have raised complex to the power complex and getting a real number. Isn't that interesting? So with this, we come to end of today's video. Please like, share and subscribe to my channel, Making Maths Fun. And also comment down in this comment section below to let me know what future videos you want to see. Thank you.